Welcome to your practice test on probability. I hope you've done some revision. Not much sense in doing a practice test unless you've revised the work. So here we have it. What I want you to do is to spend about 70 minutes, 60 or 70 minutes, because it's 57 marks, so that's going to take quite a bit of time. And what I'm going to ask you to do is to go through, scroll through, pause the presentation, and do the test on a piece of paper, because at the end, after the 9 questions, if you let the video keep rolling, you're going to see me actually go through the answers and show the marks scheme. So, are you ready? Let's get started now. Right, here's the first question. Pause it, read it, have a go. Let's come down now to part B. Which products will occur most often? You can pause it and do it at your own rate. 1 mark is just over a minute's worth of work. And part C, might have to look at your grid now to see the answers to some of these. Use the grid. And D, E then, and that's the end of question 1. Be careful, work carefully. Okay, let's go on to question 2. And part B. And part C. And into question 3. Look carefully at that diagram. You might have to come back to that diagram as we scroll through the question. And part B. Put B and C both up there. Again, you might have to go back and check the diagram. And there's D. Let's look at question 4, part A. And let's look at part B. I've got a spelling error there, too many S's there. So we'll look at part C. And question 5, part A, reading from a statistical chart there. Part B, put up B and C. Will be part 1 and 2, part 3 now. Question 6. And part A there. Part B. Question 7. And question 8. Question 9. And question 10A. Here's B. Okay, so there we have it. That's the end of the test now. And I want you to pause and check your answers, because what I'm going to do is I'm going to go back and show you how to work it all out. You can watch me working it and to mark it. So I'm going to take you back to the beginning now. Here we go, right back up to the beginning. And here we are. Put your name on the paper. Right, here we go. Let's see if I can get them all right, eh? Okay. Represent all the possible outcomes. 2 dice are rolled. Maybe underline that. And the product. Product means multiplication. Multiply. Okay. So let's come down and represent all the outcomes here. 2 dice. So here we'll have the 2 dice represented something like this. Die 1, die 2, and we've got 1, 2, 3, 4, 5, 6 outcomes. Should 6 possibilities on that roll, and up here 1, 2, 3, 4, 5, and 6. Now the outcomes are the product of the 2. So 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, 1 times 4 is 4, 1 times 5, 1 times 6. Then 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, 2 times 6. Then 3 ones, 3, 6, 9, 12, 15, 18. And 4 then, 4, 8, 12, 16, 20, 24, and 5 ones are 5, 10, 15, 20, 25, 30. Then 6s, 6, 12, 18, 24, 30, 36. Okay, so there are our possible results there. So let's mark it now. There are 3 marks there for the overall completed grid. So I want you to take off 1 if you got 2 incorrect. Take off 1 mark, only get 2 out of 3. If you only got 1 wrong, we'll forgive 1. You can still have 3 marks for that. Take off 2 for less than 5 errors, that is more than 2 but less than or equal to 5. And if you take, you lose them all if you've got more than 5 errors. Okay. All right. Okay, so make a mark there out of 3. I hope you got a few for that one. Let's go down and have a look. Which products will occur most often? Now for this we're going to have to go back and look at the grid. Which products will occur most often? So we look around there, and I think you can see the 12s, okay, through here, and the 6s, 1, 2, 3, 4. I think there's another 12 there should be there somewhere, shouldn't it? No, we've got 4. 4 of each. Okay, so that's our answer down below, so let's put that down. 12 and 6 occur 4 times each, so we've just counted them up, and that's only 1 mark. That's for a counting thing there. Find the probability coming down here that the product would be 6. Okay, so we just counted them up, so we'd put something like this. Probability of 6 is 4 out of 36, or 1/9. Only 1 mark for that. A basic probability question. Okay, let's go to 10. Find the probability of having a product of 12 on 3 successive occasions. Now this is a bit of a trap, 3 successive occasions. I want you to be analytical here. It's a probability of P equals 12, product equals 12, and another product equals 12, and the third one equals 12. By being analytical, this and this and this, it's the intersection. It's the product of each of them. Product principle, 4 on 36 by 4 on 36 by 4 on 36, or a 9th by 9th by 9th, which is 1 on 729. You can put an approximate decimal, but we're not particularly interested. There's 1 mark here for the analysis. Work in the real meaning of 3 successive occasions, this and this and this. and then 1 mark for the answer there. Okay, how are you going? Getting the hang of this probability? Being analytical is important. Find the probability of having a product of 20 on or more on 2 successive occasions. Probability of greater than or equal to 20. But what's the probability of the product being greater than 20 or equal to it? We're going to have to go back, aren't we? Come back up to the grid and see. We want greater than or equal to 20. How many are there? So it's this bunch up here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so come down, let's put that in there. 8 out of 36 are greater than or equal to 20. So we've done the first part, and then we want probability of greater than or equal to 20 on the first one and on the next one. So it's and. So again, it's a probability principle here. So it's 8 on 36 by 8 on 36, or 2/9 by 2/9. Not really wanting to pay you any marks for that simplification of the fractions. Really 3 marks there. I think you should get 1 if you do get the basic probability of 2. We could simplify it to 2/9, not necessary, and 1 for that, because it is only actually 2 marks. Should have been worth 3, that one. Okay, so you get the idea there. Okay, this analytical approach is very, very important. Let's look at question 2. A fair die, a fair coin, and an unbiased. Now look at this. They've got it in italics. Now don't read over that. That's indicating something to you. Okay, so we might have to have a look at that. Now what's a sample space? A sample space is the set of all possible outcomes. We've got an octagonal, that's 8 sides there, and a coin. So there's 2 things happening. So the sample space could be what? A head and a 1, a head and a 2. Have a system. All heads with each possible number could come up. We have a system. Okay, so we go through the whole list of heads and possible numbers. There we have it. Then we could go into the tails. So you meant to actually list all these down. This is the old way of doing fundamental probability, okay, by counting up the outcomes and that sort of thing. Okay, the set. Okay, that's a sample space, so 2 marks for that. I think you either get 2 or nothing probably there, or we might take off 1 for each error, but you'll either get the lot or not, I think. Okay, so that's the sample space, and we're going to use that in this question. Briefly explain why we can use the rule of the probability of A, where A is some event. We often call it E. The number of times A occurs, that's what this says, in the sample space out of the total number of entries in the sample space. In other words, what we're going to do is just add up the ones that constitute A. So here A is getting a head or an even number. We're going to add up how many of those there are and divide by the total. What does it assume? Okay, it assumes it requires that each member of the sample space and each member of S, you're treating them all as equal, has equal probability. So what that means is, this is why those words were in italics, that is, it must be a fair coin and an unbiased spinner, no, not weighted in any way. And those words were actually used, fair and unbiased. Let's go back up and see how did you spot those when you first read the question. Here I've circled them. And it's not a bad idea to circle things that you think are key words. These are key words because they're in italics. So that was a hint. Did you get it? All right, so you had to basically say a fair coin and a unbiased spinner. And there's only 1 mark for both of those there. Okay, you must mention both to get that mark. Okay, come down, find the probability of A using the example of A above. So what is A? Let's do it. Probability of A is the probability of a head or an even. So we want all those that have got heads or evens in them. Let's go back and count them. Heads or evens. So all of the heads, so there's 8 of those, from there right up, there's 8 of those. And then you want ones with evens, so there's some tails with evens. So these are the evens, but not heads. Okay, so there's 8, 9, 10, 11, 12, counting them up. They said we could do it if it was unbiased. So there's 12 out of a total of 16 outcomes. Okay, so we want that number over that number for 2 marks, and you could call it 3/4 if you wanted to, but not necessary here. We're looking at the probability, not at converting numbers to decimals. Okay, let's have a look at question 3. Question 3 took a bit of reading. Okay, 2 sections of a new housing estate, shaded blocks, so the shaded blocks are built on, the others are vacant. Okay, and here it's saying if the block is chosen around roads have one common fence, what is the probability of that? So there's a street in between. That's going to be important. What's the probability of it being vacant? Let's set it out in the usual way. Probability of vacant. How many are vacant? Well, we can count them up. We've got 1, 2, 3, 4, 5, 6. So that's fairly basic. That's 6 out of 24 possible houses. That's a bit of a gimme question, that is. 2 marks for that. That's a bit easy. Okay, well, let's have a look. It has a house but no neighbours. Okay, so the probability, it has a house and no neighbours. So we've got to choose how many of those fit that category. So let's go up there. It's got a house but no neighbours at all. Okay, well, let's rub all this out and pick out the ones. Got a neighbour, got a neighbour. Got a neighbour here, got a neighbour here. So this is the only one with no neighbours. So therefore it's 1 out of 24. Get the idea? Fairly basic application here. Has a house, 2 neighbours, and a house opposite the street, meaning over the other side of the street. So we've got to find those that have a house, 2 neighbours, and a house on the opposite side of the street. Well, let's have a look. This has got 2 neighbours and it's got a house on the opposite side of the street. There it is. So they will both be in it. The next one with 2 neighbours, this has got 3 neighbours, so that's not in it. This has got 3 neighbours. So this one's in it and so is this one. 2 neighbours and a house on the opposite side of the street. Is there another one? These are not in it because there's not a house on the opposite side of the street. This one's in it because it's got neighbours. This one's not in it because it hasn't got neighbours. So what do we reckon there are? I reckon there are 5 out of 24. Okay, so probability house, 2 neighbours and house opposite, if you like, is 5 out of 24. Get the idea? Not too hard, that. Now we've got to count up some more here. It has a house, so that's just a straight 2 marks. Hang on, we'll put that on there. So 1, 2. 1 for counting them up and 1 for dividing by NS. It has a house, 3 neighbours, and no house on the opposite side of the street. This is pretty simple, isn't it? It's about year 9 probability. Well, let's clean all this up and do it again for the next one. So here what we want is a house, 3 neighbours, no house opposite. Okay, well, let's have a look at how we can find that. So we want 3 neighbours. Oh, 3 neighbours, so it's got to be something like that. 1, 2, 3 around it. Or this one's got 3 neighbours, either of those 2. This one's got 3 neighbours, but we don't want a house on the opposite side of the street. So it's got to be these two here, doesn't it? No house opposite. So it's 2 out of 24. 2 out of 24, 1/12 if you like. That's 2 marks. Pretty easy marks these for counting up N, E over N, S basically. All right, let's go down to your traditional lottery question here. Raffle consisting of 200 tickets. Tom has got 9, not a bad idea to circle this. 3 prizes, so there are 3 prizes. What's the probability Tom wins the first prize? Okay, is 9 out of 200. I'll just leave it like that. You could convert it to a decimal, but we're not that interested in that at this stage. Find the chance of Tom winning no prize. Okay, the probability of no prizes. Let's get analytical about this. So there are 3 draws. So it's a probability of him not being drawn on the first, and here's the analytical part, not on the second, and not on the third. So he's got, what has he got? 9 tickets. So there are 191 other tickets that could be chosen out of 200. And then there's one of those is chosen for the first. There's 190 left, and that ticket was not put back, so it's out of 199. And then there's 189 other than his air, and it's out of 198, because each time you take a ticket, the total reduces. Okay, so that would be the answer. It's approximately, it asks for 3 significant figures, so we've got to do this. It's 0.870. So there's, there's only 2 marks here, so there'll be 1 for that, and you've got to have the significant figures. It says so. Okay. All right, come down and let's have a look at the next question. What chance does Tom have of winning at least 1 prize? Watch this, again to 3 significant figures. And the key word there is at least. So rather than go through all the possibilities, at least sometimes indicates that you can take away the complementary event. So rather than go through all the at least, that's 1 prize, 2 prizes, 3 prizes, it might be better to use the complement. Take away the fact that he wins no prizes, because we just worked that out. So that's a bus trip, this question. You're on sort of a bus trip where one answer leads to another. So it's 1 minus 0.87036, using more figures because I want to round off to 3 significant figures, and this was from the answer from B. Okay, so this is then approximately 0.130 to 3 significant figures. And we should have written this up here, 2, 3 significant figures, 3 SF. Okay. So what's this worth? This is worth 2. So 1 for that, and then 1 for the answer to 3 significant figures. If you didn't put 3 significant figures, you lose that mark. Okay, question 5. One of my favourite ideas here, when people talk about mathematics in statistics and probability land, they often say statistics and probability, because the two are intimately connected. And we're going to show you how to do that now. Statistics is about gathering data, making measurements, gathering data, representing it. And of course that can lead on to some what you might call empirical or experimental calculations of probability, and we're going to do that now. So first of all, how many days did the survey last? So we've got to try and read it off from the scale here. I think it's pretty easy. It's this one's 1, the next one's height is 6, plus 12, plus 9, plus 6, plus 3, plus 2. Just reading them off here. Okay, 12, 9, okay, and so on. So that is 39 for 2 marks. And if you got 38 or 40, only get 1 mark. Okay, so you've got to read that carefully. We're going to need that number later on, down here. estimate Fred's chances of telephoning no clients a day. Well, how many times did that occur? Probability of no clients is what? Well, only on one day did that happen. So if we take this as a reasonable sample, an estimate of Fred's chances of telephoning no clients is 1 in 39. Or we'll have a follow-through error. You could have 1 in 38 or 1 in 40. Follow-through means you've made an error, but we're going to follow through with your figures, so you're not going to be penalised over and over again. Okay, so let's have a look at the answer here. This is worth 1 mark, so that's it there. And if you had 38 or 40 up here, we don't penalise you. You've been penalised once. We're just going to follow through. Okay, at least 4 clients a day. Well, we're going to have to add them up. At least 4. At least 4. So if we go back up there and count them up, at least 4 means this one at least includes them. So if you look at that, that's 2 plus 3 plus 6 is 11. At least 4 is 11 out of 39. Or watch for the follow through. Right, if you didn't get this, you're allowed to have whatever number you had there. No more penalties. No more than 3 clients on a day. Okay, so this is, you could add up 1, 2, 3 clients, no more than. So that's equivalent to 0, 1, 2, but includes 3 because there's no more than 3. But rather than do 4 additions like that, you might say, well, what's the complement? No more than 3 means 1 minus the probability of at least 4, which was our previous answer. So we'll pinch the answer from there. Okay, so that is from 2. 2 there. So this is 28 on 39. So that saves us adding up any more. So this idea of doing that and then taking away for 2 marks there. So try not to go through a lot of probability calculations if you can use the complementary event. The complementary event. That is what's left from NS. All right. Let's go down. Let's go to question 6. I hope you're getting some marks here. Question 6, a jar problem again, white and red marbles. Seen that quite a bit. A jar is selected, so there's 2 jars, just notice that. I've given you a hint here for a tree diagram. You can do it without, but it's easier to do it with. Let's see if we can represent that. So I'll just come down here a bit so you can see it working. So with a tree you will have 3 things here. You've got to choose a jar, and then you're going to have a first draw, first draw from the jar, and then a second draw. So we need to do our tree like that. We start down here somewhere, and we go, what's the probability of jar A or jar B, and there's a 3 fifths here using a pentagonal spinner. So 3 faces are marked A, 2 faces marked B. So we're using that spinner not as part of getting an outcome, but as part of choosing which jar we'll have. Okay, so once you do that, you could draw a white or a red out of jar A. White is 4/7 because here, we go back up here now, jar A, 4 out of 7 are white, 3 out of 7 are red. And then we could go on to the second draw, white and red, or white and red. So let's go through that. After the first draw, you took out 1 white, so now there's only 2, hang on, let's have a look, 3 out of 6, aren't there? Okay, 3 out of 6, and the red for white. Hang on, we've drawn 1 white, and now we have 3 out of 6. Yep, and here if we drew the white, we've got 3 out of 6 here, correct. And then if we go to a red and then we draw a white, we'll have 4 out of 6 and 2 out of 6, because if we've done a red, it's 3 out of 7. Now we want another red, so it's only 2 out of 6. We don't put that one back. And the same thing here, white and red. So we've drawn jar B, the probability of a white is 6 out of 7 and 1 out of 7, so we're using this bunch here now. And then, oops, getting cramped, problem with trees, wasn't looking carefully enough. So here, again, a white's gone, so there's 5 left out of 6. And in the reds, no reds have gone, so we've still got the 1, see here, 1 red, so it's 1, but they didn't put the other one back, so it's 1 out of 6. Here, just a red was taken, so you've got all the whites out of 6, didn't put the red back, and you've got no reds left there. So that's the idea of each of those. You must adjust each time you take out a ball or a marble. You have one less in the total, because you didn't put it back. Okay. All right. Two marbles are randomly selected. All right. So did you get it? Using a tree enables you to look carefully through all the possible outcomes and use it. And that's what we're going to do now. So there's 2 marks for that. Determine the probability down here now that both marbles are red. Let's find the 2 reds. Okay, both marbles are red. Well, there's only one way of getting it. Jar A and 2 reds. Jar B, you can't get 2 reds. There's only 1 red in there. See this? So you've got, let's analyse it. Probability both red. Let's see what your thinking should be. Probability of A red red or B red red. Now, probably A red red is 3/5 by 3/7. A red 3/7. Hang on, just check that up there. Oh yeah, 3 red. Yep. So 3 red, yep, and 2/6. I thought it was the other way around. So 3/7 by 2/6 plus, blue, jar B is that, but you can't get a red, so that one bombs, as we saw above. And if you start cancelling some of this, that goes into that, that goes to that, so you've got 3/35. Okay, just making sure from the tree diagram, that's why I went back and checked, that you get the right probabilities following those branches of the tree along. Okay, let's look at the next one. And analysing is very important. 1 red and 1 white marble is picked from jar A. So that's a probability of jar A, red and white, or jar A, white and red. Okay, maybe we could put ands in there, couldn't I, to do a full analysis. Okay, an analytical approach. It guides what you're going to put down for the answer. So it's 3/5 by a red is 3/7, by a white is 4/6. Okay, let's just check that up here. We want A, red and white. So that's A, then red, and then white, product of those. The other one would be A and white and red. So we've got to multiply those together. So we have to pinch the numbers from up there. So OR means you will add the other possibilities, which is 3/5 by 4/7 by 3/6. and you can cancel some of those out and get, what have we got, 3, 2, 2, 2, 6 on 35 plus 6 on 35 is 12 on 35. Okay, for 3 marks. So there's a mark for some sort of analysis, a mark for that, and for a final answer there. So that's 3 marks. Did we mark this one? No, I suspected we didn't. Okay, so let's come back up here. So this is 2 marks, 1 mark for the analysis and 1 mark for the answer. Oh, no, it's 3 marks. Okay, oh well. So I'll give you a mark for that line as well. Pretty generous there. All right, let's keep going. What are we up to? Fairly long test, this one. So we're into question 7. So 3 questions to go, 7, 8, and 9. All right, so I'm going to skip there. So how do you want to do this? You could do a tree, or you could do an analysis. I think most people still want to do trees, so we'll do the tree. What are the 2 things we're looking at? Mechanical faults and faulty paintwork. Okay, we've got 0.05 and 0.02. So let's look at mechanical and paint. So our first result is mechanical okay and not okay. So okay, mechanical fault 0.05 and okay 0.95. And then paint, okay, not okay, and here okay, not okay. All right, paint okay, only 0.02 are faulty, so 0.98, 0.02, and down here the same thing. Okay, so we've set up our tree, and was probably the card selected at random will be failed. So the probability of failing using this, well, failing means what? Let's read it again. I've forgotten what it says here. And probably will fail the final due to what is probably the card selected at random. So it can't have any faults. That's the thing, it's got to be all okay. So that's this one, you can't have any faults. Okay, so the probability that it fails is all of these added up. I'm not going to do that, I'm going to do the easy way. 1 minus the probability that it's all okay, because that's 1 minus 0.95 by 0.98, because that's okay, so you want the rest of them. So rather than work out all these, take it away from 1, which is, 1 minus, I think this comes to 69 over 10,000 or something. Okay, or it doesn't ask for 3 significant figures, but you could do it, 0.069. Okay, so you use a calculator for that. So I don't know where the marks, I've got all these ticks in here now, so let's get rid of those and use the tick for a mark. So I reckon there's 1 for the tree, 1 for doing that, and 1 for the answer. You don't need the decimal answer. Okay, something like that. So if you nearly got it, you got the tree, but you didn't get the numbers right, so you're going to get part marks. So that's an important reason for doing the working and showing the working. All right, if you were game, you would perhaps do it differently. Probability of fails, you still do this line, probability of fails is 1 minus the probability of okay, which is 1 minus probability of mechanical okay and paint okay. So you don't need to treat this way if you're good at analysing, and just put your numbers in there. Mechanical okay 0.95, paint okay 0.98. So you don't need the tree if you can analyse it well enough in your own way. All right, nearly there. How are you going? I hope you're passing this. Maybe more revision is required. This is a bit of a nasty one. there are a certain number of balls in a bag. And they're doing it a bit of an algebra thing here. That many green, that many red, and 5 blue ones. A ball that shows that round is red. The probably the chosen ball was red is 7 on 29. How many red balls are in the bag? Interesting question. You've got to sort of work backwards. So what have you got? You've got what? Green, red, and blue. Now we're working with probabilities. So we really want to know the total balls in the bag to work with probabilities. So the total balls will be the sum of all of these. 2k plus 3. So what we're doing is going on unfazed because we haven't got actual numbers, we've got letters. But try to think about what you would do. 2k plus k is 3k. 3 take 4 plus 5 is positive 4. So we've got the total balls in the bag, which we're going to need because we're thinking that the probability of an event is the number of times it occurs in a sample space out of the total number of entries, which is the sum of the balls here. So this is what we're working with here, NS. Okay, so let's work through. Probability of a red is 7 on 29, so let's work that out. Probability of a red would be k take 4. Don't get phased by pronumerals. At this stage of your career, should be pretty happy with working with those instead of numbers. 7 on 29. Okay, so if we then clear the denominator by multiplying by the product of those two, it comes to that rule which you call cross multiplying, but that's not actually very good maths. You're actually multiplying by the common denominator and it's cancelling with terms on either side. So we multiply this, it's 29k, take 116, okay, multiplying it out, equals 21k plus 28. Okay, getting all the k's over on the left, subtracting 21k from both sides, you get 8k, take 116, equals 28. Therefore 8k equals 144, 4k equals 18. Alright, so let's mark that so far. 1 for that one for the expression, remembering that probably the red was 7 on 29, that was given to us. 1 for some sort of expansion there, and 1 for getting k. But we want the number of red balls, so the number of red balls we haven't finished yet is given by k take 4. So it's 18 take 4, which is 14 red. And there's 1 mark for that. So that's a total of 5 for that question. Not too bad. Okay, let's look at the last one now. Question 9, describe, this is a simulation here, describe the set of numbers generated by that command. Let's go through it. First of all, random number gives us numbers between 0 to 1, not inclusive. Okay, not including 0 and not including 1. 2 random number would give us numbers between 0 and 2, not inclusive again. 2 random number plus 1 would give us 1 to 3, again, not inclusive. Now what does int do? Int 2 random number plus 1 gives us, now, it integerises the numbers, but it doesn't round it to the nearest one. Int rounds it down, it takes it to the next integer below. So here, if we looked at them, we've got here, just explaining this, we've got numbers starting here but not including it, up to 2. So numbers there up to 2 would be rounded to 1, and numbers in the next set here would be rounded down to 2. So this is going to give us numbers 1 or 2 there. Okay, because any integer under 3 has to come back to 2. Okay, so here, I don't know, 1 mark to get there, 1 mark to get there, so a total of 2. Okay, let's look at question 10, sorry. Write a command for the calculator which would simulate a selection with replacement of a ball from a box of 3 red and 5 blue. Okay, so carefully explain what result would represent each outcome. All right, so we want to have a look at what our probabilities are. Probability of a red is 3 on 8, and the probability of a blue is 5 on 8. Now, if we used int, random number plus 3/8, that will cause us to generate numbers as integers with different likelihoods. Okay, so let's look at it. Random number plus 3/8. There's 3/8. There's 1. And let's have 1 and 3/8. Okay. So this little gap here is 5/8 wide, and this is 3/8 wide. So overall, the numbers generated, this is a probability of 5/8, and this region of numbers is a probability equal to 3/8. So these will all go down to 0, and these will go down to 1. So the probability of a 0 is 5/8. Okay, so therefore the probability of a blue is 5/8. So that will be represented by a 0, and the probability of a red is 3/8, and that would go to a 1. Okay, blue's 0, red's 1. Or you could have int, these are the easiest commands, random number plus 5/8, in which case it goes the other way. The blue goes to a 1 and the red goes to a 0. Let's just check that out then. So here, 0, 5/8, up here somewhere, 1 and 5/8. So this time, this gap has a likelihood of 3/8, and this gap has a likelihood of 5/8. 5/8 of all the numbers will occur there because it's a bigger gap. So the 5/8 probability, which is the probability of a blue, will go to a 1, because it's that group going down, and the probability of red, which is 3/8, a smaller group, will go down to 0. Okay, so either of those, one for the command and one for some sort of discussion as to what the number's going to represent, which ball, which marble or whatever. Okay, so let's have a look at the last thing. Run the program 20 times and list your results. So you want to list them. I actually did that with the first command, plus 3/8, and got these results: 1, 0, 1, 1, 0, 1, 1, 0, 0, 0, the first 10, and then 0, 0, 0, 1, 0, 1, 0, 0, 0, 0 for the 20 results. So now, empirically, or from that experiment, that simulation, the probability of a red are the ones. So there was 7 out of 20. Almost what you'd expect, 3/8. 3/8 of 20 is 7.5 or something. So that's as close as you could get it there. So it's running pretty much as you'd expect. Just remembering that program is a pseudo random processor. So you want a list of results and then a correct sum. I think I gave this 3. All right. So 3. All right. So we'll give 2 for the answer. 1 for the counting up of ones or noughts, depending on the command, and 1 for dividing it properly. Okay, so How did you go? I want you to total up all your answers there, all your marks, and it's out of 57. So I think if you could get 50 out of 57, you're going well, but we won't grade it now. I hope you enjoyed that. I hope you are ready to do some more practice for the real test so that you can do even better. So good luck with that. Cheers for now.